the cross-section perpendicular to the x-axis has the area A equals 1 over x plus 2. So rather than tell you it's a triangle, square, whatever, and you have to find the area, they gave you the area, and they're saying, okay, here's the area, find the volume. It's very rare that they give you such a straightforward one, but I think it's because there were some parts that were a little bit more time-consuming on this for yourself, on the 6 questions. So so we're going to go from 0 to 2, A of x dx, and that's going to be from 0 to 2, 1 over x plus 3 dx. Okay, this is the non-calculator section, so we're going to integrate. And this is just ln of x plus 3 from 0 to 2. So that gives you ln of 5 minus ln of 3, and that's it. That's it. So, you can, I guess. It's fine. It's fine. Either or. They'll take either. So, you get 1 point here for the integral, and 1 point for the answer, and they will take equivalent forms of the correct answer. Okay?
Oh.
All right.
And you can't do like ln of x plus 3.
X is right, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the line y equals 6. So y equals 6 is here, right? So we're rotating it around that. And so now you have to do, your big R minus your little r. So big R is equal to upper minus lower, but of the outside. So 6 minus g of x. Little r is always upper minus lower, but of the inner function. 6 minus h of x. So now, C, the volume is pi from 0 to 2, 6 minus g of x squared minus 6 minus h of x squared dx. Here you are awarded 3 points, and it was basically 2 for the integrand and 1 for the limits and the constant. So these two together, you get plus 1, and then this is fine, and then equivalent forms of this is fine. Okay. For number 6, functions f, g, and h are twice differentiable with g of 2 and h of 2 equal to 4. The line y equals 4 plus 2 over 3x minus 2 is tangent to both the graph of g at x equals 2 and h at x equals 2. Okay? So try to visualize that for a minute. If this is, x equals 2, there is some graph f g of x. There is some graph, I don't know, h of x. And then there is this line that's tangent. So you see how here they all sort of like converge and look the same, right? At that point of tangency. That's what it looks like. Find h prime of 2. What is derivative?
No.
Or slope of the tangent line. Derivative is slope of the tangent line. What is the tangent line? Y. Okay, so this is the slope. This is why when I teach derivative, I say you have to say derivative is slope, slope is derivative, slope of the tangent line, derivative is slope of the tangent line. So this is slope of the tangent line at x equals 2, okay? But whatever, the slope of the tangent line, when you're given it in linear form, it's the same slope anyway. So all you have to do is look at that equation and get the slope. So m is 2 over 3, meaning you don't have to write m is 2 over 3. So basically all you have to do is say h prime of 2 is 2 over 3.
But what makes sense is that
okay. Commentary later, please. Okay? Okay. I'll address this. One last time I will address it. We are literally in the first two words of this problem, right? So, okay, so now this is the only thing you're required to show. All you have, it's like a one-liner, and you just get +1. That's it. You don't have to write anything else except for the stuff in the blue box. Okay, number 2. Let A be this. Find an expression for A prime and A prime of 2. Okay, this is basically product rule. I want to see if you know how to do product rule and chain rule in the same problem. So, B, A prime of X is equal to, so this is product rule, right? So this is U and this is V. Okay? So UV prime plus U prime V. Okay? That's A prime of X. A prime of 2 is 3 times 4 times H prime of 2 plus 9. No, this is not 4. Sorry. It's 8, right?
Yeah.
Times 9 times 4, H of 2. So this is 24 times H prime of 2. We just found it. We said was 2/3. Plus 9 times 4. H of 2, it's given upstairs, it's 4. So all this together is 160. Okay? You get 1 point here for the form of the product rule. So you get 1 point if you used the product rule. Another point if you came up with the correct A prime of X. So together this was like 2 points, and then 1 point for this. Basically, if you attempted to do the product rule but messed up halfway, they would have given you the first point but not the second point. Okay, part C says, part C says the function h satisfies this equation for x not equal to 2. It is known that the limit of as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Okay, now, here we go, the twice differentiable part. Here it is. F, G, and H are twice differentiable functions. Yes? If something is differentiable, right? Which means it's continuous. Yes? What were the conditions for something to be continuous? If something is continuous, then the limit as x approaches 2 of a function, right? The limit exists and it equals to f of that value, correct? So here, look at what I have here. I have f of x, and then when I take a derivative, I'm going to get f prime of x. And I know that both f of x and f prime of x are differentiable, and they're both continuous. So that means, okay, it means a whole bunch of things. The limit as x approaches 2 of f of x is equal to f of 2. The limit as x approaches 2 of f prime of x is also equal to f prime of 2. That's what continuous means. So if something is continuous, the limit at a value is equal to its value at that point. So now let's apply L'Hopital's rule. Okay? The limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed is equal to, using L'Hopital's rule, 2x, the limit as x approaches 2 of 2x, and then the 1 goes away here, and I have negative 3 f of x squared times f prime of x. Okay? So now, this is equal to, okay, at x equals 2, this is 2 times 2. Okay?
You don't need to do L'Hopital.
No, because no longer do you have 0 over 0 or whatever. So then I have negative 3, f of 2, what was f of 2? F of 2 is 1. F of 2 is 1.
Yeah.
How do you know that?
Because the bottom half has to be equal to 0, because you can use L'Hopital's rule, so 0 over 0.
Oh, yes, sorry, I forgot to talk about that part. So look at this. It says that you can evaluate this using L'Hopital's rule. This means that this is 0 over 0. That means that 1 minus f of x cubed must be equal to 0. So that means f of x is equal to 1. Okay? So from that, we take that 1 and we put it here. Times f prime of 2 is 2. Okay? Okay, now, wait, what were we looking for here?
F of 2 is f prime of 2. So you just found f.
Oh, yeah.
We already know if
Sorry, I'm sorry, I completely lost track of what we were doing. Okay, so times, we don't know f prime of 2 yet. We don't know f prime of 2 yet, I'm so sorry. I'm sorry, I'll give you a lost track of thought. So, remember how this was, all of these were twice differentiable? Which means the value of the limit is equal to h of whatever. So, if this is h of x, the limit as x approaches 2 of h of x is equal to h of 2. But what is h of 2? It's 4. Okay? So all this is equal to 4. And then you solve for f prime of 2. F prime of 2 is equal to negative 1/3. So this is sort of an involved problem. So here you have to do a over negative 3 times something equal to 4. Okay? So, lots of things here. Let's review. One says, this is applicable to be solved by L'Hopital's rule. That means this is 0 over 0. If this denominator is independently 0, then you can solve for f of x at 2, or f of 2, and that's just 1. Okay? So that's number 1. This involves like half of calculus. Then, now you have to apply L'Hopital's rule, which we do here. We apply L'Hopital's rule. And then we get to this point. This is just applying L'Hopital's rule. Now here we're going to put in f of 2 from what we just talked about. And then we have an unknown. Okay? We have an unknown. So I need to set it equal to something in order to be able to solve for the unknown. Well, that comes from the fact that this is differentiable. Differentiable means continuous. Continuous means the limit at that point is equal to f of that point.
Oh, that's it.
So that's how you get the 4. Okay? So this is like 4 chapters in one part of a problem. Okay. So scoring for this, the fact that, like here, you set it equal to 4, that was 1 point. When you find f of 2, that was 1 point. Applying So here, L'Hopital's rule is 1 point. Finding f of 2 is another point. Knowing to set it equal to 4 is another point. And then this is another point. 4 points. And then, look at this. It is known that g of x is less than h of x for 1 to 3. K is a function that's in between g and h. So, if I had g of x, h of x, and then g of x, k of x is in the middle here, basically, right? From 1 to 3. Is k continuous at x equals 2? Is k continuous at x equals 2? Okay, so this is the squeeze theorem. And the squeeze theorem, we learned it at the very beginning, like back when it was like scorching hot outside. That's how, early on we learned it. And the squeeze theorem has like this, once in a blue moon, it just shows up somewhere, and then, but here's what the squeeze theorem says. Basically, if you know the limit of a function at a point here, and if you know the limit of another function at a point, then the third function in between will have the same limit. That's basically what the squeeze theorem says. So here, if they're all like very close to each other. So look at what we have here. G and H are differentiable. So again, G and H are continuous. Okay? So, the limit as x approaches 2 g of x is equal to g of 2. That's what it means to be continuous. And that's equal to 4. The limit as x approaches 2 of h of x is also h of 2, and that's also equal to 4. Okay? So now think about this. You can figure this out. Look, at x equals 2, this is g of x. The limit is 4. H of x, I don't know what it looks like, but the limit is 4. K is right in the middle. Does it make sense to you that it's going to have the same limit?
Yeah,
if it's in the middle, it can't be any other way, right? So you say, since g of x is less than or equal to k of x is less than or equal to h of x, then the limit as x approaches 2, k of x is equal to 4. Okay? Now, this is one point here for answer saying that it's continual, or for saying, with the correct justification. So saying that it's continuous with the justification. If you throw in, if you remember that this is the squeeze theorem, and if you threw it in, that's good for you. But you can, if you don't remember, you can also get away with this and not say the squeeze theorem. Okay? All right, quick questions, then we're going to move on to 2018. Notice it's a piecewise defined function. R of t is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. Hey, that sounds like an initial condition, right? R of 0 equals 20. So, how many people enter the line for the escalator during the time 0 to 300? So, you have the rate, you want the number of people, simple integration. So, in this case, for part A, you have to do 0 to 300. Because R is a piecewise defined function, you can't just put in R of t. You have to put in the actual expression. 44 t over 100. Henry has them.
Classic
dt, and that's equal to 270. So you like write down, right? Like 270 people enter over this time. So fine, right? 270 people.
I get it. It's negative.
Okay.
I'm scared about this.
So B. During the time interval 0 to 300, there are always people in line for the escalator. Right? Because as some people are entering, others are leaving, but there's always somebody there. How many people are in line at time 300? At time 300. So,
Is that just the first
so this is the, okay, so look at what happened. There were already people there when it started. Some people started coming in, some people started leaving. So now we want, first of all, the rate of change of the number of people in line. The rate of change of the number of people in line.
Oh, that's the top minus.
Yeah, that is R of t. That's how many people are coming in, minus 0.7. That's how the number of people in line is changing. Okay? So now, if you want the final count at t equals 300, you're going to do R of 0 plus the integral from 0 to 300, R of t minus 0.7 dt. This is equal to 20 plus, how much? Okay, so
20
plus,
270 minus 4.
it's, how much is it? Negative, no.
It's just complicated.
No.
Just take the integral and solve it.
Right. Okay, so you already, okay, so if you, okay, this was 270, right? Minus, what is this? 0.7 times 300, basically.
Yeah.
Okay, this is all equal to 80. So now, so 80 people at the time. Okay, now look. You get 1 point for this expression. Okay? And 1 point for this. Alright? So you have to be able to write that expression in like a calculus way.
You can
Okay.
do it either my way or your way. Like,
Once you write this, okay, you get 1 point for writing this, 1 point for this. What you do in between, up to you.
but you have to have that.
You have to have that. C. For t is greater than 300. What is the first time t that there are no people in line for the escalator? Okay, so what do we know so far? We know that at t equals 300, there are 80 people. Right? When are there ever no people? So it's still going to decrease now because look at this. It's after 300 that people stop entering. So it's going to be after 300, right? So at 300, now there are 800 people. Now it's like you cordoned off the entry to the escalator. Now you just have to wait for the people to leave. Well, the people are leaving at a rate of 0.7, right? And how many have to leave now? 80 people have to leave, right? So it has to be, so T is 300, because this is happening after the 300, plus the time it's going to take for 80 people to leave at a rate of 0.7. So if you like forget, right? What is it? It's rate is equal to like the number of people over time, right? The number of people over time. And so what you want is time, so that's the number of people over the rate, correct? So the number of people over the rate. And that's going to be 414.286 seconds. And this is just 1 point for the answer. D, at what time T is the number of people in line a minimum? Okay? Minimum means take a derivative and put it equal to 0. Okay? So, this is, okay, so what was the expression for the number of people? It was 20 plus 0 to T. Just a sec. Okay. Okay, so look at what we have here. We want the minimum over a closed interval. This is the extreme value theorem. Okay? That means, what was it? It was 20 plus 0 to 300 R of T minus 0.7 dt, right? So what you want to do is take a derivative of this. Okay? So when you take a derivative of that, what are you going to take? What are you going to get? The derivative of the 20 is going to go away. Sorry. So now you have R of T minus 0.7. That equals to 0. So R of T is equal to 0.7. You're going to plug this into your calculator. So T1, that happens twice, is 33.013298. T2 we're going to plug in what R of T is the actual value for R of T from up there.
And then plug in
This,
0.7 and then find
this.
No,
Listen to me. You're going to plug this in, Y1, Y2.7 on the calculator, see where they, okay? So now, these are your critical points. So now, by the extreme value theorem, what you want is you want to evaluate this at 0, T1, T2, and so on. So let's say that this is A of X, right? That's the number of people, that's the expression A of X for the total number of people in line, correct? So now, for the extreme value theorem, what you want to do is you want to evaluate A of 0, A of 300, these are your round, endpoints, and then A of 33.013, A of 166.574. So A of 0 is 0. Oh, no, it's not. It's 20, remember? We knew that from way before. A of 300, we just said was 80. This one is 3.803. And then 158.070. So now, you say, the number of people in line is minimum at t equals 33.013 seconds, and there are round and just say 4 people in line. Don't abbreviate people like that. I just did it here. Okay, so let me show you. You get 1 point here, so set that equal to 0. 1 point for, 1 point for this, all of it, and then 1 point for this. Yes.
So you know how you right? 38.01.
I would, yeah, I would.
Then you could get an answer.
That's about like you're going to be storing.
Yes. That way you
Store and then, yeah.
Isn't it?
I don't know where that was.
Do whatever. You can just round it.
Choose which one.
It's like 0.14. The chunk 0.014.
Yeah, it's fine. Yeah, that's the point. 0.01467, let's say, right? And let's say you can write either 0.014 or 0.015. They'll take both. They won't take 13. They won't take 17 or whatever. Okay. Okay. A particle moves. Oh, I love these ones. A particle moves along the x-axis with velocity given by v of t for time 0 to 35. 3.5. The particle is at position x equals -5 at t equals 0. Okay? So x of 0 is -5. Find the acceleration of the particle at t equals 3. Yay, we can do that. That's the derivative. So, part A, you say you have to write v prime of 3 is equal to, okay? Uh-huh. Okay, I'll tell you. You know what? Let's do it in more condensed form. Here's what you're going to do. Yep, this is what I want you to do. Okay, do you remember how to take a numerical integral, a numerical derivative with your calculator?
Yes.
That's what we're going to do, right? So you're going to go here.
Do we have to write out the equation first?
No. Here, this one. No, that's not the one.
3, yes, no. X 3, first derivative.
Where is it? Is that in here?
It's 4. No, it's not.
Okay, yeah, so then just go to menu. Yeah. Okay? So that's what you do. And you get -2.118. If you just write this, you get the full point. That's it. B. Find the position of the particle at t equals 3. So now, you want x of 3. This is equal to x of 0 plus the derivative, the integral, from 0 to 3, v of t dt. This is equal to -5 plus the integral. You plug it in your calculator, and you get -1.760. Okay? Okay, you get 1 point for this. I'm saying that there is an integral. You get 1 point for this. and obviously 1 point for this. Part C, evaluate 0.0 to 3.5 V of t, and then absolute value of 0. Whatever. Okay, so here's how you write it. 0 to 3.5 V of t dt. You already have done this before, right? You just did it in part B. So you take that, and all you have to do is change the bound, and you're done. Don't put in anything new, okay? So you get 2.844. Then you get 0 to 3.5 V of t dt, 3.737. Now, we love these. Interpret the meaning of each interval text of the problem. So you're going to say 0 to 3.5 V of t dt is equal to, or is, sorry, the displacement of the particle over the interval 0 to 3.5. If you want to do interval notation, go right ahead. Is the total distance traveled, use that word total, over the interval 3 to 5, 3.5. D. I'm on the wrong page for my question. A second particle moves along the x-axis with position given by x2. At what time t are the particles moving with the same velocity? So, you want, okay, so here's where it's super important to label properly. So what you're going to do is V2 of t is equal to x2 prime of t, right? And that is 2t minus 1. And then you say v of t is equal to v2 of t. You can either say this, you don't have to rewrite like that whole equation with the sign, blah, blah, blah. Don't write it over. You can either say this, or you can say, v of t is equal to 2t minus 1 at, plug it in. So here's what you're going to do. Plug this into y1, plug y2 equals 2t minus 1. They are the same at t equals 1.571. Okay? You get 1 point for this, 1 point for this. Okay, now,